going on, everybody? Moving on with chapter 11, 11.3. We're talking about surface area today of prisms and cylinders. Okay, just like always, the notes and PowerPoint slides are up on Canvas, so follow along with the video while you have those pulled up as well. Okay, so the big difference between area, which we did, perimeter and area, which we did in 11.1 and 11.2, now in 11.3, working with surface area, that brings us to the difference of 2 versus 3-dimensional figures, right? So 2D or 2-dimensional figures are flat. The 2 dimensions are width and length, base and height. Imagine when we think about parallelograms, think of just drawing a square, a triangle, a circle, etc. on just a piece of paper. It's flat. There's no dimension, third dimension to it. There's just 2 dimensions, right? So 3D or 3-dimensional figures have depth as well, right? Think of a box as a 3-dimensional. Think of a water bottle being 3-dimensional. There's 3 different directions you can have the figure being drawn. Okay, and so what's going to help you a lot when you're doing 3-dimensional shapes is being able to deconstruct 3D shapes into multiple 2D shapes, right? So if you think of a cube, how many squares make up a cube, right? Think how many sides are on a dice, right? There's 6 sides on a dice. Therefore, there are 6 squares that make up a cube, right? So deconstructing shapes like this creates what we call the net of a shape, right? Doing this, we can see all sides of a 3D shape much easier, which will help us calculate the surface area. So if we imagine, all right, here comes my very poor attempt at drawing a 3-dimensional cube, right? If we look at this cube, it's a picture of a cube, so it's not an actual cube. We can essentially only see 3 sides here. But when we deconstruct it and turn it into a net, we can see all 6 sides, right? And sometimes when you see 3-dimensional figures, you'll have dotted lines, and dotted lines represent what is not shown, but what you know is there. So again, 3 sides, there's 4 around the sides and a top and a bottom. So that makes 6 sides in a cube. Okay, so now surface area is the total area of the surfaces or faces of a 3D figure. Think, if the area of a 2D shape is the amount of space inside the shape, the surface area is just adding up all of the areas of the multiple flat surfaces or faces that create a 3D shape. Or you can think about it as the amount of space that covers the outside of a 3D shape. Okay, so that's what we mean when we say surface area, adding up all of the faces or sides of a 3-dimensional shape. Okay, and here are 5 types of 3-dimensional figures. Ideally, if we had more time in the school year, we would talk about all 5 of these for surface area, and then in next lesson, we'll talk about volume. But again, we're just running out of time, so we don't have enough time to go through all 5 of these. It's still important you know about these, but for the purpose of this lesson and for this school year, we're only going to be focusing on prism and cylinder. But anyways, a prism is a figure with 2 parallel and congruent faces with sides being parallelograms. So a prism can actually take on the shape of many different shapes. The most common things that we will see for prisms, or at least in this class, we will only see parallel or quadrilaterals and triangles. But if you think about a prism, it can take on the shape. You can have the faces be any shape. It could be a pentagon, a hexagon, anything that you want. It could technically be a non-regular shape. But anyways, you don't have to stress about that. A cylinder is a figure with circular or oval faces and then straight parallel sides. A pyramid is a figure with a base. Typically, the base is a quadrilateral or a triangle. Technically, again, you can have many different types of bases, but all of the sides are going to be triangular, and all of the triangular sides slope up to a point at the top. A cone is a figure with a circular base that tapers to a point. Imagine a pyramid, but just with a circle as the base. So it technically doesn't have any sides. It's just going up. A sphere is a round 3D figure with each part of its surface equidistant from its center. Think of a ball. Okay, and here's a bunch of pictures representing those. So remember, right, this is a prism, and this is also technically a prism. This is a quadrilateral prism. This is a triangular prism. Again, like I said on the last slide, it can be a bunch of different shapes, but those are the 2 shapes that we will see. This is a cylinder, right? The 2 faces or the 2 bases are circles, and then parallel lines on the side. This is a pyramid with a square base. This is a pyramid with a triangle base, and this is a cone with a circle base, and this is a sphere. Okay, so surface area of a prism, depending on what shape your bases are, find the area of all of the surfaces and add them together. In this class, like I said, we'll only work with quadrilateral and triangular prisms. So if you review and we think, remember, surface area is just adding up all of the surfaces together. The area of a parallelogram we talked about already is area is base times height. The area of a triangle is base times height divided by 2. So if we take a look at these examples, again, creating nets is really going to help you visualize a little bit better. So remember, we got 6 sides in a rectangular prism. I'm going to transfer those numbers over across. So that would be like this side is 14. This side is this. All of these lengths here are 14. Let me use a different color. All of these lengths are going to be 9. So that's a 9, that's a 9, that's a 9, and those two are 9s. And then the remaining ones are going to be that 6. So if I use a different color, this is going to be 6, 6, 6, 6, 6. Those at 6. Those there are 6s as well. All right. So there. Remember, surface area is just finding the area of all of these different sides and then adding them together. Okay, so if we just take a look and we use a calculator to help us calculate those out, this square, or this rectangle, the area is going to be 14 times 9. That gives us 126. This is going to be the exact same rectangle, so that's going to be 126. Okay, this one, if I use a different color, I'm kind of running out of colors, but if we look at this, this is 9 times 6, which is going to give us 54, which means that those two are the same. And then our last pair is going to be 6 times 14, which gives us 84. All right, so now we have all 6 sides accounted for. Right, 2 sides are 126, 2 sides are 54, and 2 sides are 84. So we just add all those together. So 84 plus 84 plus 84 plus 84. I think I said that wrong. 84 plus 84 plus 54 plus 54 plus 126 plus 126. That gives us 528. Right? If we add together all of these surfaces, all of these areas combined together give us 528. Okay, over here, now we have 2 triangles and 3 rectangles. This is a triangular prism, right? So if we imagine this triangle, this side length is going to be 18, which also means that this side length is also going to, these 2 side lengths here are going to be 18. The diagonal side lengths, we do not know those diagonal side lengths, so that's unfortunate. We're going to have to find those out. But we can know that these side lengths here are 24. This one here is going to be 24. And then this picture and this picture obviously were not done together, so it doesn't quite look like it, right? But that means that all of these sides here are going to be 8s. All of the blue ones are going to be 8s. All right, and then we don't, like I said, we don't know the diagonal sides. I think I've already used that color. Sorry, let's use that one. Right, in pink, we don't know the diagonal sides, but we can use Pythagorean's theorem to find that side, right? Because that is the triangle that we have there. 24 and 18 are legs. That missing side is the hypotenuse, so we end up having Pythagorean theorem. 18 squared plus 24 squared is going to equal x squared, and we just multiply those out. 18 squared becomes 324, plus 24 squared becomes 576, equals x squared. All right, and then if we add together 576 plus 324, that gives us 900, equals x squared. Right, that ends up being a really nice, easy square root. The square root of 900 ends up being 30, so x is equal to 30, which means now we know that these lengths here are 30. That's 30, this one's 30, that's 30, this one's 30, there. Okay, So now we just find the areas of all the different sides and we add them and combine them together. Okay, remember, area of a triangle, we have two triangles. Area of a triangle is base times height divided by 2. So the base is going to be 24 times the height is 18 equals 432, but then we divide by 2. So that means both of the triangles end up being 216. So both of the triangles are 216. Right? This rectangle here is 8 times 18. So 8 times 18 gives us 144. Right? This middle rectangle is going to be 24 times 8. All right, so 24 times 8 gives us 192. All right, and this last one over here is going to be 8 times 30. So 8 times 30 gives us 240. Right, and so we just add all of those together, 216. But remember, there's two triangles, so plus another 216, plus those three rectangles is plus 144, plus 192, plus 240. That gives us an answer of 1008. Okay, so that is surface area of prisms. One was a quadrilateral prism and one was a triangular prism. Okay, surface area of cylinders. A cylinder deconstructed into a net forms two circles and a parallelogram, right? So if we imagine a cylinder, the tops or the two bases or faces are circles, and then if we were to unwrap the thing that connects them, it would end up being a rectangle. Therefore, you find the area of the two circles and the parallelogram, and again, add them together. Surface area means finding the area of all of these faces and adding them together. However, how can we find the length of the rectangle? It is actually going to end up being the value of the circumference of the circle. So imagine, once you roll this rectangle up, right? If you fold these sides of the cylinders down to be the top and bottom, think of it like a can, and then you wrap the rectangle around, the length, or this side right here, ends up being the value of the circumference because it has to touch all sides of the circle. Therefore, the equation for the surface area of a cylinder is 2 times pi times radius squared. So remember, pi r squared is the area of one circle, but there's two circles, so you multiply it by 2. Pi times r, 2 times r is the value of a diameter, and diameter times pi is the length of the circumference, so that will give you the length of the rectangle, times the height is going to be that there. Okay, so if we take a look at these examples, right, I'm going to write out that equation because it's kind of long and annoying and difficult to remember sometimes. So remember, you have 2 pi r squared, that represents the two circles that you have, plus 2 pi r, that is the circumference, times the height, right? So do these two together because that ends up being the value of the rectangle. All right, so here in this example, this is a diameter of 15. So diameter of 15 is not helping us, right? So we have to find the radius. 15 divided by 2 gives us a radius of 7.5. So here our r is equal to 7.5. So we just plug these in, 2 times pi times 7.5 squared plus 2 times pi times the radius, which is 7.5, times the height, which we see here is 18. Okay, so plugging those into a calculator, first do 7.5 squared. Let's see, 7.5 times 7.5 gives us 56.25. Then we times that by 2. Then we multiply that times pi. Which this whole chunk here gives you a value of 353.429. And then if we calculate all of this here, if we do 2 times pi times 7.5 times 18, that gives us 848.23. And then if we add those two together, that gives us plus 353.429 that ends up giving us 1,201 point, and we will round it to 0.6. All right, so that is the surface area of that cube. Okay, over here, remember r equals 8. The radius in this instance is 8, so 2 times pi times 8 squared. I'm just going to do that right now, which is 64. 8 times 8 is 64. Plus, we do 2 times pi times the radius, which is 8, times the height, which we see here is 12. Okay, so again, calculating that out, 2 times pi times 64 gives us this chunk here, gives us 402.123. Hey, that's kind of fun. Plus, and then we do this separately, 2 times pi times 8 times 12 gives us a value of 603.185. We add those two together, plus 402.123 gives us a value of 1005.3 and rounded to 3. That is your surface area of that cylinder. Okay, so as you can see, the equations are a lot more complex, but in the end, it's just plugging in the numbers into the equation and letting the calculator do the rest. Okay, so don't worry too much. Okay, like I said in the beginning, there's technically 5 shapes that we should be doing this about. We don't have the time. Here are the deconstructed nets of different shapes, just for funsies, right? This is a deconstruction of a cone. The equation for surface area of a cone is even more complex because if you think about it, this shape here, this deconstructed cone part, isn't even a shape that we've learned. The area of the deconstructed net of a square-based pyramid is pretty simple, right? It's just a square and 4 triangles. And then this is the net of a triangular-based pyramid. Again, it just comes out to 4 different triangles that you have to find the areas of. And then when we take a look at a sphere, remember a sphere is like a ball, right? This is just an example of a net of a sphere. As you can see, it is way more complex, right? The equation of surface area of a sphere is pretty complex, and it makes sense, right? These are all these shapes, right? And the reason why I put a basketball here is, right, we can think of a net of a sphere because it's because it's curved, not twisted, because it's curved. We're not going to have edges, right? We don't have good edges. So if you think about all of these different panels of a basketball and imagine peeling them off of a basketball, that would give you a net of a sphere. Okay, but again, we don't actually have to work with this. This is just for fun. So just 2 more lessons, ladies and gentlemen, this one and the next one. Have a great day. Go Mustangs.